This is our Year 7 Reactions Reverse the Classroom activity. Right, so you're now getting information before you actually complete the unit to give you a good idea about what's going to be coming up so that then you can understand things better. What it goes through chemical reactions, burning fuels, conservation of mass, thermal decomposition, exothermic and endothermic, and then energy level diagrams. You then go for a review, and then you've obviously got end of unit assessments. Now, one of the first things you've got to do is you've got to know when a chemical reaction has happened. Often, if there's a colour change, there will be a chemical reaction that has happened. If there is a temperature change, there will be a chemical reaction that has happened. So that could be getting hotter or getting colder. If sound is given out, there's a pretty good chance that a chemical reaction has happened. New product formed. And then the last one is if there is fizzing, any bubbles or gas or anything like that given off, again, a chemical reaction. So they are then the 5 signs that a chemical reaction has happened. Now, comparing a chemical change with a physical change, right? So what I'm going to do, and when you say compare, what you do is you deal with each kind of row at the time. A physical change is reversible. So for example, freezing water. What you can do, you can freeze water, you can melt it. You can freeze water, you can melt it. Irreversible means it's cooked, all right, and it's chemically changed, it's changed. So you've got an egg to start off with, a raw egg, you cook it, the outside kind of clearish bit, right, becomes white, and that means there's been a chemical change. But it is irreversible, which means you can't take it back again. A physical change, there's no new product. You freeze water, it's still water. If you melt water, it's still water. With a chemical change, a new product has formed, and in the case of an egg, you've got different proteins. In a physical change, what's actually happened is the particles are being rearranged. So you freeze water, they all kind of line up. You melt water, they all become more random. Particles in chemical change are when they are actually broken apart and reformed. Now, the fire triangle, right? There's loads and loads of different versions of fire triangles. So what I've got here is you've got to have fuel, you've got to have oxygen, and you've got to have a high temperature. You've got to have fuel, you've got to have oxygen, and you've got to have heat. If you take any one of them away, the fire goes out. Take away the oxygen, you've got your fuel, you've got a high temperature, but you now have no fire. Now, complete and incomplete combustion. What I'm going to do here is I'm going to draw a lovely blue Bunsen flame, and here what I'm going to do is I'm going to draw an orange flame. Okay, Bunsen flames. So incomplete combustion. What you'll have is only water and carbon dioxide is made. So complete combustion, you only get water and carbon dioxide. It is a clean flame, right? So it's a lovely blue clear flame. And what's actually happening here is the hydrocarbon fuel is oxidized completely, right? Hence why you only get water and carbon dioxide. In an incomplete combustion, you get carbon dioxide, which is what we had before. You get water, which is what we had before. And we get carbon monoxide, which is a deadly, nasty, poisonous gas. And if you see carbon dioxide being produced in combustion, that means that there is incomplete combustion. What you do is you get the orange flame, but you also get particulates coming off, which is black bits, purely the carbon dioxide and the water. Law of conservation of mass. Matter cannot be created or destroyed. All the atoms of the reactants are found in the products. So whatever you start with and whatever you end with, you've got the same amount of stuff in each at the start and the end. Thermal decomposition. Thermal decomposition is self-explanatory. Thermal means heat, decomposition means breakdown. Now the example that's being used in this is calcium carbonate, which is a carbonate. What you do is you heat it up. When you heat it up, carbon dioxide gas comes off. You know it's carbon dioxide gas because you pass it through lime water, and if you pass it through lime water, you get a white precipitate. That is then carbon dioxide test. And the chemical formula here is calcium carbonate, and what you do is you make calcium oxide and the gas carbon dioxide. Exothermic and endothermic, we've got 2 reactions that are going on here. Think about when you go to the cinema. What door do you go out of? You go out of the exit, which means out, and it's to do with heat. Theoretically, the door going in should be the endo, I guess, right? But obviously it isn't. An exothermic is where heat is transferred to the surroundings. That means it comes out. And it also, an exothermic means there is a rise in temperature. So any exothermic reaction, it gets hotter. Endothermic reaction, whereas heat is transferred from the surroundings. So heat actually goes in. And that is indicated by a fall in temperature. So you've got a reaction going on and the reaction gets colder, that means it's endothermic. Here's another little table that explains it. So exothermic reactions, energy is given out to the surroundings. Something called delta H is negative, and the products have less energy than the reactants. Endothermic reaction, energy is taken in from the surroundings. Delta H is positive, products have more energy than their reactants. Now, there's two graphs I'm going to go through. This is an exothermic reaction. Okay, I'll start off with green. Here, you start off with the energy of the reactants. This is then the energy of the reactants. What you then do, you have to put some energy in, which is called the activation energy, which is this. And that is the energy required to actually start the reaction. When the reaction starts, the reaction continues, and gets down to here. This is then the energy of the products. And what you'll notice is the energy of reactants is higher than the energy of the products, which means energy is released to the surroundings, right? Surroundings, right? And that is an exothermic reaction. An endothermic reaction does work in a similar kind of way. You start off with the energy of the reactants, you put energy in to start it off, which is the activation energy. Then what happens is the reaction happens and we end up here. And now you'll notice that the energy of the products is higher than the energy of the reactants, which means energy has been absorbed from the surroundings. Now, these are then the 5 questions. Give 5 signs of a chemical reaction. I want 5 things. What is the law of conservation of mass? I want a sentence. What is a physical change? Give me a definition. Draw an exothermic graph. What gas is produced by the thermal composition of calcium carbonate? I literally just want the name of a gas. Now again, the idea of that then is understanding, right? Now if there's anything from this video that you don't understand, Google it, right? Because Google is fantastic, and then what you can do then is you can then find out more information about the topics that are coming up.